Hello students, welcome back. So we are doing trigonometry exercise 21E, isn't it? In our previous videos we have completed till question number 9 and today we'll start from question number 10 onward. Okay, so let's begin. So this is question number 1 of 10. Prove that. We are asked to prove left hand side equals to right hand side. In the left hand side we are provided with 1 upon sin A minus cos A minus 1 upon sin A plus cos A. We are going to use this and prove this equals to this. Okay, so let's begin. First let us copy the left hand side. LHS equals to 1 upon sin A minus cos A minus 1 upon sin A plus cos A, isn't it? So this is what we have in the left hand side, cos A. So let us take the LCM of the denominators. Suppose we have 1 upon A plus 1 upon B. How do we take the LCM of these two denominators? We just simply multiply A and B, isn't it? AB. Now A into B gives us AB, so that B into 1, B plus B into A gives us this AB, so A into 1 is A. We write in this way, isn't it? Similarly, we multiply these two. Okay, now here you can see sin A minus cos A into sin A plus cos A gives us, let's assume this sin A as A and cos A as B. Okay, A minus B into A plus B, isn't it? When we multiply these two numbers, sin A minus cos A into sin A plus cos A, we can see that A minus B into A plus B, isn't it? This means A minus B into A plus B can be written as A square minus B square. This is formula, isn't it? So you can write this as A square minus B square. Okay, so sin A minus cos A into sin A plus cos A gives us this number. So sin A plus cos A into 1 sin A plus cos A. Okay, so now minus sign comes here. Okay, now sin A plus cos A into sin A minus cos A gives us this number. So sin A minus cos A into 1 sin A minus cos A. Okay, so here we have sin A plus cos A minus into plus minus sin A, isn't it? So minus into minus plus cos A. In the denominator we have sin square A, this minus comes here. Cos square A can be written as 1 minus sin square A, isn't it? 1 minus sin square A means cos square A. You know that sin square A plus cos square A equals to 1. So cos square A equals to 1 is already in the right hand side. So let's take this sin square A to the right hand side minus sin square A. So cos square A can be written as 1 minus sin square A. Instead of this cos square A, I am writing 1 minus sin square A. Okay, so this minus plus sin A and minus sin A can be cancelled. In the numerator we have cos A plus cos A, that is 2 cos A, and in the denominator we have sin square A minus into plus minus 1 minus into minus plus sin square A, isn't it? So let me continue here. This means we have 2 cos A in the numerator, so no need to change this. 2 cos A upon, so sin square A is plus and this sin square A is also plus. Same sign means we must add these two numbers. Sin square A plus sin square A gives us 2 sin square A. 2 sin square A, isn't it? So this minus sign, minus 1 comes here, isn't it? Sin square A plus sin square A, 2 sin square A minus 1. So this is what we have in the right hand side, equals to RHS. Hence proved. I hope you got this. Now let's move on to next question, question number 2. Let us do question number 2 of 10. Okay, so cot square A upon cosec A minus 1 we have this in the left hand side and we are asked to prove this equals to cosec A in the right hand side. Okay, so let's do this. LHS equals to LHS, left hand side equals to cot square A upon cosec A minus 1, isn't it? This minus 1 comes here. Okay, so cot theta can be written as cos theta upon sin theta, isn't it? Cot theta means cos theta by sin theta. So cot square A can be written as cos square A upon sin square A. Okay, cot square A is cos square A upon sin square A, because cot theta is cos theta by sin theta. So this cosec A minus 1, cosec A minus 1, this minus 1 comes here. So let me copy this cos square A as it is, cos square A. Now let us multiply this sin square A into cosec A. Okay, sin theta equals to 1 upon cosec theta, isn't it? Sin theta is the reciprocal of cosec theta. Sin theta can be written as 1 upon cosec theta. We all know this. So let's cross multiply this. Sin theta into cosec theta equals to 1, isn't it? Sin theta into cosec theta means 1. So sin square A into cosec A, sin square A into cosec A equals to, you see here, sin square A means there are 2 sin A, isn't it? So 1 sin A and 1 cosec A is cancelled, because sin A into cosec A is 1. Okay, let me explain this in better way. Sin square A means sin A into sin A. Okay, sin square A means sin A into cosec A, into cosec A. Okay, so this sin A comes here, sin A. Now sin A into cosec A, sin theta into cosec theta is 1. So sin A into cosec A is 1. So sin A into 1 is sin A. Are you getting me? This means sin square A into cosec A is sin A. Okay, now minus sin square A into 1 is sin square A. Sin square A into cosec A is sin A. This minus comes here. Sin square A into 1 is sin square A. This minus 1 comes here. Okay, now let me continue here. So now let us take the LCM of the denominators, sin A minus sin square A into 1, isn't it? When we take the LCM, we must multiply these two numbers. So the LCM will be sin A minus sin square A, sin square A. Sin A minus sin square A into 1 is sin A minus sin square A. Okay, now this number sin A minus sin square A, 1s are this, isn't it? This number when multiplied with 1 gives us this number. So that 1 into cos square A is cos square A. Now this minus sign comes here. Okay, so 1 into sin A minus sin square A gives us this number. So this number into 1, okay, means sin A minus sin square A. Sin A minus sin square A. Okay, so we have cos square A here, cos square A, minus into plus, minus sin A, minus into plus, minus sin A, minus into minus, plus sin square A. And in the denominator, let's take sin A common. Sin A is taken common here, sin A. So if sin A is taken common, we have 1 within the bracket, minus plus into minus gives us minus, sin A into sin A, sin A into sin A gives us sin square A, isn't it? So you can see cos square A plus sin square A. This is cos square A plus, okay, there is no sign in front of cos square A means plus, Plus cos square A plus sin square A is 1, isn't it? Sin square A plus cos square A gives us 1. This is formula, isn't it? Sin square A plus cos square A is 1. So this cos square A plus sin square A can be written as 1 minus this is sin A whole upon this sin A comes here into 1 minus sin A. Okay, this 1 minus sin A and 1 minus sin A can be cancelled. So we have 1 in the numerator, 1 upon sin A. Now let us take this sin A to the numerator. This becomes cosec A, because sin and cosec are reciprocal of each other. So sin A when taken to the numerator becomes cosec A, isn't it? So this is RHS, right hand side, hence proved cosec A. So let us do question number 3. Okay, now let us do question number 3 of 10. So we have cos A upon 1 plus sin A in the left hand side, and we are asked to prove this equals to sec A minus tan A, isn't it? So let's do this. LHS equals to cos A upon 1 plus sin A. This is what we have in the left hand side, isn't it? So now let us take this cos A to the denominator, isn't it? You know that cos theta equals to 1 upon sec theta, because cos theta and sec theta are reciprocal of each other. Cos theta can be written as 1 upon sec theta. So this cos A, if we take to the denominator, becomes 1 upon sec A. Okay, cos A can be written as 1 upon sec A into, we have 1 plus sin A, 1 plus sin A, 1 plus sin A. We copy as it is. So 1 is in the numerator. Now let us multiply this sec A with this number. Sec A into 1 is sec A, isn't it? Plus sec A into sin A is sec A sin A. Okay, sec A into 1 is sec A, this plus comes here, sec A into sin A is sec A sin A. So 1, instead of 1 we need sec A minus tan A, isn't it? So instead of 1 I can write sec square theta minus tan square theta equals to 1. Sec square theta minus tan square theta is 1. This is the formula, we know this, isn't it? So this 1 can be written as sec square A minus tan square A. Sec square A minus tan square A means 1. Sec square theta minus tan square theta means 1. So instead of 1 I can write sec square A minus tan square A. So this is sec A, okay, plus this is sec A, isn't it? Sec A, if I take this sec A to the denominator, if I take this sec A to the denominator, cos theta equals to 1 upon sec theta, isn't it? Sec theta equals to 1 upon cos theta. Cos theta equals to 1 upon sec theta means sec theta equals to 1 upon cos theta. Sec theta and cos theta are reciprocal of each other. Okay, so sec A, if I take to the denominator, becomes cos A. Sin A by the sec A goes to the denominator and becomes cos A. Okay, now let me continue here. So sec square A minus tan square A. Now let's assume this sec A as A and tan A as B. Okay, so A square minus B square can be written as A plus B into A minus B whole upon sec A plus, this is sec A, okay, sec A plus sec A plus sin A by cos A means sin A by cos A is tan A, isn't it? Tan A, because tan theta equals to sin theta by cos theta. This is the formula which we already know. Tan theta means sin theta by cos theta, isn't it? So instead of sin A by cos A, I can write tan A. Okay, so this sec A plus tan A and sec A plus tan A can be cancelled. So we have sec A minus tan A left. Sec A minus tan A is left. So this is what we have in the right hand side, equals to RHS. Hence proved. I hope you got this. Now let us do question number 4. Let's do the next question, that is question number 4 of 10. We have cos A into 1 plus cot A plus sin A into 1 plus tan A in the left hand side, and we are asked to prove this equals to sec A plus cosec A, isn't it? So let's copy the left hand side first. LHS equals to cos A into 1 plus cot A plus sin A into 1 plus tan A. Okay, so this is cos A. 1 plus cot A can be written as cos A by sin A, isn't it? Cos A by sin A. Cos theta by sin theta is cot theta, so cot A is cos A by sin A, plus this is sin A. 1 plus tan A means sin A by cos A. Okay, so now let us assume 1, because there is always 1 in the denominator if there is no number, isn't it? So we take the LCM of the denominators. Okay, 1 and sin A. The LCM will be sin A. Sin A into 1, sin A. Because 1 into sin A gives us this sin A, so sin A into 1 is sin A. So sin A into 1 gives us this sin A, so 1 into cos A is plus cos A. Okay, so this plus comes here. Here we have sin A into, we do the same thing here. The LCM of 1 and cos A is cos A. So cos A into 1, cos A, plus 1 into sin A is sin A. So this cos A upon sin A, cos, let me write properly, okay, cos A upon this sin A can be written as here, this sin A, cos A upon sin A into sin A plus cos A, sin A plus cos A, isn't it? So plus this sin A and this cos A I write here, okay, into cos A plus sin A. Cos A plus sin A means sin A plus cos A, same thing, isn't it? Plus cos A plus sin A. We don't change the sign, we simply change their places. Okay, cos A I write later, sin A in the front. I can do that, isn't it? So we have sin A plus cos A here and sin A plus cos A here, same number, we can take the common out. Sin A plus cos A is taken common out, so within the bracket remains cos A upon sin A, cos A upon sin A, plus this sin A plus cos A is taken out. Now this cos A plus upon sin A comes here, so this plus sign comes here. This sin A plus cos A is taken out. Now sin A by cos A comes here, sin A by cos A. Okay, so let me continue here. Sin A plus cos A I copy as it is, sin A plus cos A. Now I take the LCM of the denominators, sin A and cos A. Okay, sin A into cos A is sin A cos A, sin A cos A. Now sin A into cos A gives us sin A cos A, that means cos A into cos A, cos A square A, cos square A, plus cos A into sin A gives us sin A cos A, so sin A into sin A, sin A square A, sin A square A, isn't it? This means sin A plus cos A I write here, sin A plus cos A. So cos square A plus sin square A means sin square A plus cos square A, same thing, isn't it? This means 1 upon this sin A cos A, sin A cos A. Okay, sin square A plus cos square A or cos square A plus sin square A means 1. So in the denominator we have sin A into cos A, so I multiply this with 1 here and 1 here. We have 1 here and 1 here, isn't it? If there is no number in the denominator, we should understand there is 1. So sin A into cos A into 1, sin A by, we have sin A in the numerator, by sin A into cos A into 1, sin A cos A, isn't it? So this plus sign comes here, this plus, cos A I write in the numerator as it is, sin A into cos A into 1, sin A cos A, cos A. So this sin A and sin A can be cancelled, and this cos A and cos A can be cancelled. We need sec A plus cosec A, isn't it? So if I take this cos A to the numerator, it becomes sec A plus this sin A, if I take to the numerator, it becomes cosec A, isn't it? Equals to RHS. Hence proved. I hope you got this. Now let us do question number 5, okay? Okay, now let's do another question. Question number 5 of 10, okay? So we are asked to prove this equals to this. So let's copy the left hand side first. LHS equals to sin A minus cos A into 1 plus tan A plus cot A, isn't it? This is what we have in the left hand side. We are asked to prove this equals to this. So let's copy this as it is, okay? Sin A minus cos A. So we have 1 here, 1 plus tan A. Let's change this into sin and cos form. Tan A means sin A by cos A, isn't it? Tan A means sin A by cos A, plus cot A means cos A by sin A. Okay, so this is sin A minus cos A. Now let us take the LCM of the denominators. Okay, here we have 1 in the denominator of 1, here cos A and here sin A. So the LCM will be sin A into cos A, sin A into cos A, cos A into sin A, or sin A into cos A, same thing, isn't it? So 1 into sin A, 1 into cos A sin A gives us sin A cos A, isn't it? So cos A sin A into 1 is sin A cos A, or cos A sin A, cos A. 1 into cos A sin A gives us sin A cos A. So this number into 1, sin A cos A, plus cos A into sin A gives us sin A cos A. That means sin A into sin A, sin A square A, plus sin A into cos A gives us sin A cos A. That means cos A into cos A, cos A square A. Okay. Now please don't think of writing this as 1. Okay, sin square A plus cos square A is 1. We know that, but don't write that, because we have another formula in mind. Here we have sin A minus cos A. Let's write this sin square A first. Okay, plus sin square A means plus sin square A. Now this plus sin A cos A, plus, there is no sign means plus, isn't it? Plus sin A cos A, okay, plus cos square A. I am just changing their places, okay? Nothing is changed, the value is not changed. And in the denominator we have sin A cos A into cos A. So this can be written as whole like this. So you know that A cube minus B cube equals to A minus B into A square plus AB plus B square, isn't it? This is the formula from algebra, we know this. A cube minus B cube means A minus B into A square plus AB plus B square, isn't it? So let's assume this sin A as A and cos A as B. Okay, A minus B, A square plus AB plus B square. A minus B, A square plus AB plus B square. A minus B, A square plus AB plus B square means A cube minus B cube. This means A is sin A, isn't it? a cube minus b cube. B is cos, so cos cube a whole upon sin a cos a, isn't it? So I write separately, okay? Sin a cos a upon sin a cos a. If I take the LCM, it becomes like this, isn't it? So here we have sin a multiplied 3 times, isn't it? Sin a into sin a into sin a. Sin cube a means sin a into sin a into sin a, okay? And in the denominator we have sin a into cos a, sin a into cos a, okay? Now this sin a and sin a can be cancelled, so what remains is sin into sin a, sin a into sin a. Sin a into sin a is sin square a, isn't it? Are you getting my point? I hope so. Here we have sin a multiplied 3 times, and in the denominator we have 1 sin a, so that 1 sin a and 1 sin a cancels out, so sin square a remains in the numerator. Sin square a upon cos a, okay? Minus, same thing here, cos multiplied 3 times and cos a, that means cos square a upon sin a, okay? So let us take this cos a to the numerator, because we need sec a upon cosec square a, isn't it? So let us take this cos a to the numerator and sin square a to the denominator, okay? What happens is cos a goes to the numerator and becomes sec a. Sec a, cos a and sec a are reciprocal of each other. So if I take cos a to the numerator, it becomes sec a. Now if I bring down this sin square a to the denominator, it becomes cosec square a, isn't it? Cosec square a, because sin a and cosec are reciprocal of each other. So if I bring down this sin square a to the denominator, it becomes cosec square a. Minus, minus comes here. Same thing goes here, sin a goes to the numerator, cosec a, cosec a, cosec a upon cos square a. Cos square a, if I take down to the denominator, it becomes sec square a. So this is what we have in the left hand side, isn't it? Sorry, right hand side. So this is equal to RHS, hence proved, okay? I hope you got this. This was for today. Thank you so much. I'll continue the remaining question in the upcoming video, okay?